This is my solution for task 8.2. So I have this solve method, but I also have a breadth first search method here, and I have one other method called checking the neighbor. So first, obviously, the solve method is called from the testing files. So it performs. I'll just run through it. I create two lists of tuples to store cells in when the breadth first search method finds a cell with a wall in it. But in order to store the cell, I've created tuples for the row and column coordinates, which represent that cell. So I create two different tuples. Two different lists of tuples, because I actually call the breadth first search twice, one from the top left cell and one from the bottom right cell. So each of these two breadth first searches take in one of these lists. So this breadth first search from the top left cell will end up filling or populating this list of tuples with the walls that it comes into contact with first. And the second breadth first search populates another list with all the walls it comes into contact with. And it's only if what this little part here does is it just goes through that one of those lists and looks through every cell that's in that list. If it's also in the other list, then we've found a wall that can be broken, which is what the whole task is about. And it just adds these cells up and returns the number of cells that were in both of those lists. So let's look at the breadth first search method, which is up here. So it takes in a whole bunch of stuff. Obviously, it returns the list of tuples, but it takes in the entire matrix. It takes in the list. Currently, the list is empty. It takes in the size of the matrix, and it takes in the starting position, which for the first call is 0, 0. For the second call is n rows, n rows minus 1 and n columns minus 1. So I've got this. I initialize another matrix, which is the same size as the matrix passed in, and this matrix is to keep track of which cells have been discovered. And I create a queue of tuples so basically this is a queue of the cells, but the cells are represented by their row and column, or the XY coordinates. So here we create a new little tuple cell with the row and the column of the current cell, which is 0, 0 for the first call. Add that to the queue, and we set the discovered matrix of those same coordinates to 1, so we've marked the cell as discovered. And then this is the normal breadth first search while loop, while there's still elements of cells in the queue, keep going. So get the cell tuple from the queue, and then we have these 4 if statements. Because with this task, the cells are able to be travelled to up, down, left and right. So there'll be 4 neighbour cells. So each one of these corresponds to checking the below, the cell to the right, the cell above and cell to the left. This if statement just checks that we're not at the matrix boundary, because obviously if we're at, for the first call we're at 0, 0, you can't check the cell above or check the cell to the left because there are none. So these are just kind of making sure that we don't get any out of bounds errors. And then each one of these calls this check neighbor method on that there corresponds to the below cell, because cell item 1 is the row and cell item 2 is the column, so that's getting the below cell, so it's in the next row. And so we'll just look at the check neighbor. So again, it basically takes in all the same information. as well as which cell we're at. So it's just checking, has this neighbour been discovered yet? If it hasn't, then we create a new cell tuple called the neighbour. We label the neighbour as having been discovered. We check if that neighbour cell is empty, so is there a wall or is there not a wall? If there's not a wall, we add it to the queue. But if there is a wall, we then add that to the list of walls. And so that goes through in the same way that breadth first search checks adjacent cells. And then that goes through, runs through. When there's none left in the queue, it returns the list of walls. And then again, it's called on from the bottom up, and that returns a list of walls. And then, yes, as I said before, this compares the two lists, and we return the final count of walls. And it works. And it works at pretty good speed too, pretty similar to the requirements.